All right, so we're going to talk about the difference between factoring an expression and solving by factoring. And some students get a little bit confused about when you do what. And really, this is a pretty easy thing to determine. The very first thing I would suggest to you is read the directions. Often the directions will give you explicit instructions on what to do. It will say, factor the quadratic expression, or just factor, period. Okay, and if that's the case, you're going to use the techniques that we've discussed prior to this, using a GCF, breaking down a quadratic into pieces that could be solved or factored by grouping, etc. However, maybe the instructions are going to tell you to solve by factoring. And if that's the case, we've got an additional step. And you can often recognize this type of problem because we have now put an equal sign in the mix. Okay, so what we're really looking for when it says solve is what are the value or values that we can substitute in for x and satisfy this equation, make it a true statement. So we're going to try this one. We're going to take this 3 and we're going to move it to the other side of the equation. We want to set this equation equal to 0. You're going to do this with any equation that has a degree higher than a linear term. Okay, so let's move everything to one side. We're going to do that by subtracting 3 on both sides of the equation. 5x squared plus 14x minus 3 is equal to 0. Okay. Now what we're going to do is we're going to look and see, do these 3 terms have any kind of common factor that I can divide out? And in this case, there's not. So now I'm going to use that technique we talked about before, where we take this first term and last term and multiply them together, 15x squared. And then we want to think about things that are factors of 15 that will break apart and make this 14. So let's think about our factors of 15 for a second. There's only 2 sets. There's 1 and 15, and there's 3 and 5. So let's think about this. What 2 numbers multiply to make 15, yet subtract to make 14? Okay? Which 2 numbers multiply to make 15, but subtract to make 14? And that answer is the 15 and 1. So this is now going to break apart into 15x and 1x, and of course we don't have to actually write the 1, it's implied. All right, so which of these is which sign? With this negative, we got to have one of each, but the larger of the 2 will take the sign in front of this linear term. So this one will be positive, while this is negative. And now we're going to bring down the first and last terms and make this ready to factor by grouping. So let's take a look at this first group, and let's think about the GCF would be 5x, and then we'd have x plus 3. Bringing down the sign and thinking about what is a GCF of x minus 3, and that's just 1. And now divide out that negative 1 from these 2 things, and we have x plus 3. Now I can take the GCF out of this piece, this whole piece, and this whole piece, and that is x plus 3. And if I divide that out of the first piece, I get 5x. And if I divide it out of the second piece, I have minus 1. So in all these cases, this is equal to 0. So this is where we have to finish the problem. We need to take each of these factors and set them equal to 0. And we have to do it for each because we think about that zero product property. The zero product property says, if I multiply 2 factors together and I get a result of 0, then one or both of those factors must be 0 itself. That's the only thing that you can multiply and get a result of 0. So I'm going to take this x plus 3 and set it equal to 0. And I'm going to take the 5x minus 1 and also set that equal to 0. So I'm going to subtract the 3 to the other side, and I'll get x is equal to negative 3. And I'm going to subtract the 1 over to the other side and divide through by 5. And I'm going to get x is equal to 1/5 here. So my solution set here is -3 and 1/5. Now, always a good idea is to go back and substitute. So let's take a second and try this one. We have 6x squared minus 54x equals 0. We see the equal sign, which means we want to solve it. And everything is already to one side of the equal sign, so I can just go ahead and take a look at it. First thing is I'm going to look at that first step of factoring, looking for a GCF, and there is one, lucky me. 6x squared and negative 54x, I think I can take a 6x out of both of these things. And if I divide the 6x out of the 6x squared, I get x. And if I divide the 6x out of the negative 54x, I get 9. So it's factored, but it's not solved quite yet. So I take both of these factors, 6x, and set it equal to 0, and x minus 9, and set that equal to 0. And in this case, x is equal to 0, or x is equal to 9. So my solution set is 0 and 9. Two examples. We're going to solve this one, and we're going to solve it by factoring. So I see this quadratic, messy quadratic, because it's not anywhere near standard form, and I want to get it in standard form, and I want it all to be on one side of the equation. So let's first move this negative x to the other side. Let's distribute through the 6, and then let's see if we can rearrange the terms so they're in standard form, and then take a look at it. So I'm going to distribute 6x squared minus 12. I'm going to move this negative x to the other side, plus x, and set that equal to 0. Now what I want to do is take these two things and switch their order. They're not changing over the equal sign, so they're going to keep their signs. They're just going to switch order. 6x squared plus x minus 12 is equal to 0. I look for a GCF and I don't see one. So I'm going to go ahead and multiply these two things together, and I have 72x squared. And I want to think of factors of 72 that subtract to make 1. Well, definitely I've got 1 and 72, and I've got 2 and 36. I think I have 3 and 24, and 4 and 18. I could go through this list all day. 6 and 12, 7, 8, and 9, and that would be the end of my list. Now thinking about on this list, what two things can subtract to make 1, and that would give me this, right? So I end up with 6x squared, 8x, 9x minus 12 equals 0. Now I need signage here. They've got to be one of each, and the larger one needs to be positive. So this is positive while this is negative. Now let's factor this by grouping. GCF here is going to be 2x, and we have 3x minus 4. GCF here is just going to be 3. And again, I'm going to have 3x minus 4. So I end up with 3x minus 4 times 2x plus 3 is equal to 0. Set each of these equal to 0 and solve. 3x minus 4 equals 0. 2x plus 3 is equal to 0. Adding 4, 3x is equal to 4, and x is equal to 4/3. Here, subtracting 3, 2x equals negative 3, and x is equal to negative 3/2. Okay, let's try this last example. In this case, we have an equation. Only one term is on the right-hand side. Let's move it to the left. So 6x squared plus 23x plus 7 is equal to 0. Now let's take these two things and multiply them together and get 42x squared. Now, of course, you're looking for a GCF, but I recognize that 23 is prime and 7 does not divide into it. Of course it can, it's prime. But there are no common factors. I really want to check that first because that really does make life easier. Okay, so let's think about factors of 42 that will add to make 23. I've got 1 and 42, I've got 2 and 21, I've got 3 and 14, no 4, How about 5, no, 6, and 7? So which of these add to make 23? That would be this. So we would end up with 6x squared, and we'd have 2x and 21x, and plus 7. All right, both of these have got to be positive. All right, so let's go ahead and set that equal to 0, right? And factoring by grouping again. 2x, 3x plus 1, plus 7 times 3x plus 1 is equal to 0. 3x plus 1, 2x plus 7 equals 0. Each of them equal to 0. Subtracting 1 and dividing by 3. Subtracting 7 and dividing by 2. So our two answers are negative 1/3 and negative 7/2. All right, that's where we're going to wrap this one up. And we'll see you next time when we talk about something new, different, and exciting.